I'm driving a car, this car is rotating around the circle, or any object rotating around the circle, and this circle with the radius r, my velocity is constant. Assume it 20, and here is 20. Again, my velocity is constant. That is a wrong sentence, right? My speed is constant, yes, but my velocity is not constant. Why? You can tell me. This is my velocity. Speed is because it is tangential to that circle. Why my velocity is not constant? Online, can somebody write it here in the chatting? I think you said the answer. Why my velocity? The speed is constant, but the direction is not the same. Yes, right. It is not opposite, it's a different direction. Sometimes it will be here, sometimes it will be here, sometimes it will be here. My tangential speed is the same. I study for a constant speed, but not constant velocity. I have a change in velocity. Because I have a change in velocity, I have acceleration, right? Thank you for this word. I think I talked about that from before. When we write this vector, Vi, and this is V final, they are the same speed. I need to find delta V. It is equal to V final minus V initial. This is V final. This is V initial. Flip it because it has a minus sign. Because V final minus. This is minus V initial. This is the difference between them. Because I have it V final plus minus V initial. This is delta V. Over delta T, we have time always. This is acceleration. Because we have two far points, this is average acceleration. But if we need that to find the instantaneous acceleration, we need to measure them just after 0.11 second, for 0.001 second. Here, for example. And I have this vector, and I need minus V initial, it will be like this. Then the acceleration will be to this direction. I have this acceleration, centripetal, to the center. And I told you, the Earth has a centripetal acceleration to the Sun, and the Sun also to the center of Earth. Actually, to the center of their mass. Okay. We can derive what is the acceleration, the centripetal acceleration, or radial. I name it here radial. Simply, I'll give you the relation. I will not derive it. I'll name it a radial. Radial to the radius is equal to V squared over R. Maybe R capital or R small. R capital we have it. V is the tangential velocity. Tangential. It's simple to be. A is V squared over R. That's it. This V is not the velocity, it is the speed. It is constant. R is constant. The acceleration will be constant in this case. Okay. Now we will deal with some math, with some geometry for a circle. The circumference is equal to 2 pi r, or r capital. If we have a constant speed, then we will rotate it by a time. This time is capital T, which is named period. From the velocity low, the distance, which is this distance, I name it S, is equal to the velocity. I'm sorry, is equal to the speed multiplied by the total time, which is the period. Okay, what is the period? It is the circumference, which is S, over the speed, which is V, tangential. Right? This is V. It is equal A multiplied by R and the square root or something like that. So from here, V is equal to S over T. This is over 1. S multiplied by 1 is equal to T multiplied by this. You can exchange them. V is equal to S over T. V squared is equal to S squared over T squared. You can put it here. S is equal to 2 pi R. Then you can find another relation. V squared is equal to 4 pi squared R squared over T squared. Also, the acceleration will be equal to 4 pi squared R over T squared. Put them as you see them here in your formula sheet and use them when I ask you about that. What? Now we have acceleration. Newton exists in our life. And he appeared and looked at us when he listened and heard about acceleration. We have AR or a radius. Yes. If we have a mass, if this object has a mass, Newton would tell us that there is a force. It is equal to M multiplied by A. A is given. The mass is, any object has a mass. A is V squared over R. R capital or R small, you are free to do this. This is F. Because A is radial, then F is radial or centripetal, which is the central force. It's Newton's second law, just like that. M A, this is A, the acceleration V squared over R.